Alright, hello everyone. Today we are going to go into another part of your bonding, which is the hydrogen bonds. Alright, so previously I already completed everything about ionic bonds and also the covalent bonds. Alright, so today we are going to go into another type of bonding. Okay, hydrogen bonds. So first thing that I need to stress about hydrogen bonds is that this type of bonding is actually a type of attractive force, okay, between molecules. All right, okay. You need to what do you call be careful, okay, of all the bondings that you learn in this chapter. You need to know which type of bonds are between atoms, which type of bonds are between molecules. All right. So normally the ones that are between molecules we call them attractive forces. Okay, so example is your hydrogen bond, and then another one will be your van der Waals forces. So normally your hydrogen bond and also your van der Waals forces, they are always compared with each other, all right, in terms of their strength and also in terms of their what they call melting point and boiling point. All right, okay, so we need to remember this thing. All right, so that's why we say that hydrogen bonds are the is a type of attractive force. Okay, so this attractive force is formed between, since we say hydrogen bonds, right? So definitely it's between hydrogen atoms with high electronegative atoms. All right. So the three high electronegative atoms that you are learning here is nitrogen, fluorine, and oxygen. So in other words, hydrogen bonds are formed between hydrogen and these three atoms. Okay, but remember it's between molecules. All right, so this is an example, a depiction of the hydrogen bonding here. All right, so remember, okay, first the bonds between the hydrogen and the oxygen inside one water molecule. Okay, so this one here is actually your covalent bond, right? Okay, so this one is covalent bond. Okay, now oxygen, this is very high, or we say high electronegative element. Electronegative element. Okay, so the attractive force here between the oxygen and the hydrogen forms what we call the hydrogen bond. All right. Okay, so if let's say I were to draw another example or another water molecule, all right, so it will be like this. So let's say if I have oxygen, H and H, right? So normally this will be the hydrogen bonds right here. Okay, and then if you want to draw another one, you can draw a lot. All right, so let's say I draw another one here. Doesn't matter how. All right, just remember that the attractive force is always between high electronegative elements and the hydrogen atom. All right, but it must be between different molecules, not same molecule. Inside the molecule is what we call covalent bond. Okay, so the three electronegative elements that you need to learn is this one: nitrogen, fluorine, and also oxygen. All right, so basically you can have three different types or three different examples of hydrogen bonding. Okay, so an example is between O and H, all right, or between nitrogen and hydrogen, or between fluorine and hydrogen. All right, so three different examples of hydrogen bonding. Okay, so remember it's between molecules. All right, so most likely because you are learning this, it's a new thing in your Form 4 syllabus, all right, compared to previous year. So most likely, what I'm guessing is that they might ask you to draw the hydrogen bond, meaning they might ask you to show an example of the hydrogen bonding, meaning roughly you need to know, okay, how to sketch or draw a example of hydrogen bonding, but I hope they won't lah. All right, okay, so we need to explain, okay, the hydrogen bond. So this is how we explain. All right, so first we say water molecule, okay, because this one is between water molecules, consists of one hydrogen atom and oxygen atom. Oops, sorry, between one oxygen atom and of course we have two hydrogen atoms. All right. Okay. So over here, the oxygen. Here we need to mention which element has the high electronegative is the high electronegative element. Okay, so oxygen atom has high electronegativity. Okay, and then we mention the attraction forces between oxygen atom in water molecule with hydrogen atom. Okay, you need to include this in your answer from another water molecule. All right. So to show that you understand that the formation of the bond is between two different water molecules. Okay, that's why you need to put in the or the keyword here, the key phrase here. All right, keyword here. Okay, attraction force between oxygen and hydrogen from another water molecules to form hydrogen bonds. Okay, so basically that is how you write your explanation. Okay, so be very careful of your terms that you use. All right, make sure to include this word here. Okay, all right, so next let me show another example of your hydrogen bonding. Okay, so this one is between hydrogen and fluorine. All right, hydrogen fluoride molecule. All right, so I'm just going to show you here. Okay, so this H bonded to the F here in the molecule here. This one is the covalent bond. Right, so remember, whereas this one between molecules, okay, so the fluorine the fluoride from the hydrogen fluoride molecule and also the hydrogen from another hydrogen fluoride molecule, this one here is the hydrogen bond. Okay, so basically the explanation, all right, will be based on the example here. All right, you just change the uh, name of the molecule. Okay, consists of, for example, here is hydrogen atom and fluorine atom. All right, and then which one is the electronegative element? Remember, okay, the electronegative elements: oxygen, nitrogen, and fluorine. Okay, FON, phone. All right, remember, electronegative. Okay, E phone. All right. So the explanation later on, you just refer to the top part here. All right, and also for the ammonia. So basically, you need to know how to explain the formation of hydrogen bonds between these three molecules: water molecules, hydrogen fluoride, and also ammonia. All right. So here, as you can see here, right? Okay. So this one in the middle here, this is an electronegative element, nitrogen. Okay, and then you have an attractive force. Okay, so this is the hydrogen bond. All right. So all right, that is the hydrogen bond. Okay, it's basically an attractive force between a hydrogen atom, which is a positive, with a electronegative element, which is the negative ion. Not ion, the negative what they call element. All right. Okay, so that is it. Okay, the first part of your hydrogen bond. Okay, it's very simple. You're not going to learn very difficult things. Alright, so this is where they're going to ask you questions on the effect of hydrogen bonds in your daily life. Okay, so why do our hair sticks together when wet? Oh my god, sounds so ridiculous, right? Hair wet also got reason, but everything that happens in this world has a reason, right? So it's like this. Okay, so basically each strand of our hair here, okay, inside each strand of hair we have protein molecules, and inside each strand of hair, okay, if you see here, inside each strand of hair they have the hydrogen bonds, okay, between the protein molecules. All right, now what happens when you have water? Basically the water will act like a glue. If you imagine it, okay, the water will act like a glue. It's going to stick two different hair strands together. All right, so if I were to, oh my god, okay, obviously my drawing is so bad. Oh my god, I can't believe I'm drawing this. Okay, So this is one hair strand. One. Crap. Okay, and this is another one. All right, so inside each hair strand we already have the hydrogen bonds between protein molecules. So when you have the water here, right, so what happens is that this water molecule will somehow behave like a glue. So how do they glue your two different hair strands? Is by hydrogen bonding. Okay, they form hydrogen bonds between two different protein molecules. Okay, like the one in the middle here. Okay, so as you can see here, this is from another hair strand, this is from another hair strand. So two hair strands combined together, that's why it will stick. Okay, so the reason why they stick is because of the hydrogen bonds. Alright, so when hair is wet, okay, your protein molecules of hair forms hydrogen bond with water molecules. Okay, and the water molecules will form hydrogen bonds with another protein molecules. So you see, this word here makes a huge difference. Alright, so that is why your hair will stick together. Okay, so why your hair will look straight? Same reason actually. Alright, so when it's dry, okay, basically your hair, they have your hydrogen bond, right? So when it's wet, different hair strands will stick together. Okay, so basically it's like almost the same as the explanation on top. Alright, so as you can see here, when curly hair gets wet, the protein molecules form hydrogen bonds. Okay, and then they form hydrogen bonds with other protein molecules and stick together. That is why it becomes straight like this. Okay, if you see my hair here, oh my god, it looks so ugly. Alright, so I have wavy hair. Okay, so that is the reason why and then this one if you go to anywhere, if you go to any, like for example coffee shops or in school or whatever, you will see everybody using their saliva. Okay, dirty. All right, your saliva, and then they are going to count their money. Okay, you take the saliva and then you count your money. Okay, why? Because they stick, right? But why do they stick? Okay, the reason why is that because they have the hydrogen bond. Okay, so basically because your papers, all right, are made from cellulose. Okay, remember, it's made from cellulose, so they have hydrogen and oxygens. All right, so what happens is that in your saliva, basically because it's water, right, so your wet finger here, okay, since you have water, will form hydrogen bonding with the hydrogen in the cellulose. Okay, so it's going to stick. So that's why it's easier for you to turn your pages when your hand, when your fingers are slightly moist, okay, or wet. All right, so this is the explanation right here. Okay, they have the hydrogen and oxygen atoms, cellulose. All right, so water molecules, hydrogen, will form hydrogen bonds with the oxygen atom in the cellulose. Okay, and then the paper will stick onto the paper. All right, so it's not necessarily like only got one hydrogen bond. As you can see here, it can be like this also. Right, that is why as long as you have the oxygen and the hydrogen, and as long it's from a different molecules that are going to form the hydrogen bonds. Okay, so it's not only one bond, you can have a lot. Okay, depending on the molecular structure. All right, so that is the example, okay, of how hydrogen and bonds affects your daily life. All right, so this one is the most important thing, very very important. Okay, the effect on melting and boiling point. So remember, your hydrogen bonds will be used to compare with van der Waals forces. Okay, so you need to know which one is stronger. All right, so in general, okay, in general, the strength of attractive force, I already highlighted here, hydrogen bonds are stronger than van der Waals forces. So remember, if you are stronger bond, meaning you are going to need more heat energy, so your boiling point or your melting point will be higher. So you remember the basic concept first. Substance with hydrogen bonds will have a higher melting and boiling point compared to those with the van der Waals forces. Okay, so we are going to look at the comparison between two different types of substance here, compound here. All right, one is ethanol, another one is chlorine. Okay, so if you look at your ethanol molecule here, all right, so this is one molecule of ethanol. This is another molecule of ethanol. So these two, okay, inside this molecule here, basically you can have two different types of attractive forces. One is van der Waals forces. Van der Waals forces exist in all covalent compounds, right? All covalent compounds will have van der Waals forces. Okay, but hydrogen bonds, okay, can only exist in compounds or substances that has high electronegative elements, meaning you must have the oxygen, nitrogen, and fluorine. Only you can form hydrogen bonds. Okay, so in the case of ethanol molecule, we have van der Waals forces, and then we also have water. What they call a hydrogen bond, not water. Here, okay, we have both or two types of attractive force. Okay, so when you have two types of attractive force, right, of course, your melting and your boiling point will be higher, okay, because although this one is easier to break, but you still need to break off the water molecules, right, in order for it to evaporate or melt or boil or whatever, all right. So basically, you are going to need more heat energy in order to break off the hydrogen bonds. Okay, that is why the melting or boiling point of ethanol will be uh, higher compared to those that only have van der Waals forces. Okay, so for example, if you look at my table right here, I already did a summary, some sort like a summary lah. All right. So in ethanol, you have two types: hydrogen bonds and van der Waals forces. Okay. So strong hydrogen bonds. Okay, remember to put the keyword here. Strong hydrogen bonds is difficult to break. Okay, compared to van der Waals forces, right? But hydrogen bonds will always be weaker than your ionic and covalent, right? So more heat energy is needed to overcome the van der Waals forces and hydrogen bond. Okay, so I have two forces that I need to break here. That's why I'm going to need more energy. Whereas for chlorine, right? Okay, Cl. Okay, this molecule here, no hydrogen, no oxygen, no fluorine, no what they call nitrogen. So meaning they cannot form hydrogen bonds with water molecule. Okay, even if I have water, right? But because they don't have the electronegative elements or even the hydrogen, nothing here. So they cannot form hydrogen bond, right? So if you don't have hydrogen bonds, meaning in between chlorine molecules, for example, this is one molecule, this is one molecule, you are only going to have van der Waals forces only, right? Since they cannot form hydrogen bonds with water. Okay, so they only have van der Waals forces. So less heat is needed, therefore their melting and boiling point will be lower. Okay, so to know whether a covalent compound, all right, have van der Waals or hydrogen bonds will depend on whether they have the uh, what they call elements needed to form hydrogen bond. So you just remember a very simple thing. If I want to form hydrogen bond, it must be between hydrogens and the three electronegative elements. Okay, meaning I must have this thing. All right. Okay, one of the molecules must have hydrogen, the other molecules must have these three, either of these. Okay, then only you can form hydrogen bonds. Right. So those, for example, like ethanol that can form hydrogen bonds with water means they are soluble in water. So basically, solubility in water, you can what happened to my English today? You are able to soluble in water is because of two reasons. Number one is if you can ionize in water. Okay, for example, like ionic compound, your NeCl, right? Okay, so ionic compounds, when you put it inside water, they ionize to form ions. So this is the first reason you are able to solubilize in water. Second reason that you can solubilize in water is if you can form hydrogen bond. Okay, so technically speaking, if you can form hydrogen bonds with water, right, meaning you are soluble in water. Okay, that's why I put the note here. All right, so ethanol can form hydrogen bond with water. Therefore, this one is soluble in water. This one cannot form, so it's not soluble in water. So you need to know, or you need to be able to deduce whether this compound or this substance is able to solubilize in water or not. So how? It's just based on whether they can form water, what we call hydrogen bonds with water molecules. Okay, so I can already imagine the type of question that I'm going to ask you. all right? So maybe they are going to do the very classic way, this one X and Y, something like that, and then X, okay, forms, and then maybe they will give you a certain, what do you call, characteristics. This one forms hydrogen bond with what, this one forms hydrogen bond with what, and then they will ask you to deduce whether this one is soluble in water or not, and then they will ask you to explain. So I can roughly imagine the questions, all right? So that is the story about hydrogen bonds. Okay, it's very simple, very direct, all right, and it's only very little. Okay, so the important thing is that your explanation. Okay, when you explain anything about hydrogen bonds, okay, make sure you have the keywords. Okay, oxygen, high electronegativity. Okay, and then attractive force. Okay, attraction force. All right, and then with another water molecule. So all these are the important things that you need to write in your answer. Okay, so that is it for your hydrogen bonds. Okay, the next part will be about dative bonds. Okay, I'll see you in the next video.